video is about the quadratic formula, and so it is a method that you can use to solve a quadratic equation, and you can use this method for any quadratic equation. You're not limited by anything. So you can always use this. Before you begin to use this though, you want to make sure that your equation is in standard form, which is this form right here. Ax squared plus bx plus c. If it's not in this form, you need to manipulate your formula through algebra to get it in this form. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. So we're going to solve number one. What is the quadratic formula? It's this, and it's derived from the method of completing the square. That's where we get this from. And it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you haven't memorized this, I think it's a great idea to memorize it because you use it very, very often in math. And so there's a lot of good ways to memorize it. If you look on the internet, there's songs that you can learn to sing it to and different stories. They have all kinds of ways you can learn to memorize it. I just learned to memorize it straight, just memorizing it. There's kind of a flow to it. So however you put it in your head is a good thing to do. All right, so let's solve number one using this formula right here. So first you say, hey, is this in quadratic form, standard form? And it is. And so you say, what is the leading coefficient? What is a equal to in this case? So for number one, a is equal to 1 right here, b is equal to 6, and c is equal to 13. So to solve, x is going to equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So what you've seen me do right here is set myself up for success no matter what kind of problem I'm solving. If I use parentheses to enclose my numbers in, my negatives will not be messed up and I will be okay. So I recommend that. So once you've decided that, let's go in and put in our values. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then from here on out, we're going to use order of operations to evaluate this. So negative 1 times 6 is out here. We can just call that a negative 6 plus or minus. Now, if you've never seen the plus or minus symbol before, what it is it's a convenient way of writing two separate statements. So if, for instance, you have x is equal to plus or minus 3, this means that x is equal to 3 or x can equal to negative 3. It's two separate statements. So you'll see that as we go, but that's what that little symbol means right there. Okay, so let me get that off the board so we have room for the rest of this. Negative b plus or minus the square root of b squared, 36. Oops, I didn't mean to change colors there. 36. And then right here, I think this is an important thing to do. See how many negative signs you have. These are being multiplied. So if you have a negative times a negative, if there's two negatives, that will turn the expression positive. If you have one negative, it will remain negative. If all three of these numbers were negative, if you had a negative times a negative times a negative, that would make it negative. So if there's an odd number of negative signs, it's going to be a minus. So there's 1, which is an odd number, it's going to be minus. If I have a negative times a negative, which is 2, which is even, it will turn it positive. So this is a mistake or a place where I see a lot of people kind of go off a little bit. So 4 times 13, oh my goodness, what is 4 times 13? Let me just do this. 12, 4, 5, it's 52. 52 all over 2 times 1, 2. So make sure that you put this big, long division symbol. Many times I see students write it just over that part, but that is incorrect. It goes over the whole thing. Okay, so over here, this is going to be negative 6 plus or minus the square root. 36 minus 52. Let me just do the math. I have to borrow. That's a 6. That's a 4. I get 16. I get negative 16. All right, all over 2. This is equal to negative 6 plus or minus. What will we do with this? Well, we learned that the square root of negative 1 is the imaginary number I. So we're going to pull out the I and then take the square root of 16, which is 4, all over 2. Here, I'm going to split my plus or minus. This is negative 6 plus or minus 4i over 2 negative 6, negative 6 plus 4i over 2, negative 6 minus 4i over 2. Now these can be further simplified. 2 can go into the negative 6, and so this could really be negative 3 plus 2i, because 2 can go into the 4. So there's one of my answers. 2 can go into the negative 6, negative 3. 2 can also go into the negative 4 minus 2i. So in this instance, we got 2 imaginary numbers. I'm just going to take note of that. I'm going to have to erase some of this so we'll have more room, but let me just take note of number 1. We got 2 distinct imaginary answers. Actually, they weren't purely imaginary, they were complex numbers. They had a real part and an imaginary part. Okay, that is just something I wanted to take note of. Let's go on and do number 2. So if we're going to do number 2 by the method of quadratic formula right here, then we got to say, is it in standard position? Is it in ax squared plus bx equals to c? This right here. And it is not. We don't have a 0 on one side, we have a 6. So we have 2 options. They're both equally fine. You can subtract 6 from both sides and get a 0 on one side, or you could move all these terms over here. You will get the correct answer either way you do it. So I'm going to choose to move all these over to the left and get a 0 over here. So if I do that, I'm going to have to add 4x squared to both sides. So I get a 4x squared. If I say plus 4x squared, that will give me 0. Plus 4x squared will give me 4x squared. Minus 3x plus 6 is 0. Now this is in standard form, ready to go. Now I know that A is 4 right here, okay. B is negative 3 and C is 6. X is negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So I'm going to go in and put in my values now. It's negative B or negative 3 plus or minus the square root of B squared, negative 3 squared minus 4 times A, which was 4, times C, which was 6, all over 2 times A, which is 4. Let me make sure I'm happy with that. Negative B plus or minus square root of B squared minus 4 times A times C all over 2A. Yes, that looks fine to me. Now we use order of operations. A negative 3 is a positive 3 plus or minus the square root of negative 3 times negative 3 is a positive 9. You'll always get a positive number in this position right there, because a negative times a negative is a positive, and a positive times a positive is a positive. Right here, count the number of negative signs. We have 1, so we only get 1 right there. So it's going to be 4 times 4 times 6, 16 times 6. Oh my goodness, I have to do so much multiplication today. Okay, this is 6, that's a 3, 6, it's 96 minus 96 all over 2 times 4, which is 8. All right, great. Let's do this. 96 minus 9 is going to be an 87. I think it's 87. Is that right? Let me see. Yeah, so this is going to be 3 plus or minus the square root of negative 87 all over 8. In an 87, is there a 3 in there? I don't know. Let me try. Is there a 3 in there? Let's see if I can simplify that radical a little bit. 3 goes into this twice. That's a 6. That's a 27. Oh, yeah. 3 times 29. But still, there's nothing I can take the square root of. So that's got to stay like that. That's okay. But we can and we must do something with the I. So I'm going to move it up here. This is 3 plus or minus I times the square root of 87 over 8. If we need to separate our answers, one would be 3 plus I square root of 87 all over 8. 3 minus I square root of 87 all over 8. Okay, in this case, what did we get? We got 2 distinct complex roots like the last one. So let's just take note of that. Here we got, for this one, right here, I'm going to just leave it at this form. We got 2 distinct complex or imaginary, I should say complex roots. All right. Let's do this one, number 3. Alrighty, ready. Number 3 goes like this. Is it in standard position? No, it is not. So let's put it in standard position by getting a 0 on one side. So what I'm going to do there is I'm just going to simply add 25 to both sides. 4x squared plus 20x plus 25 equals to 0. Now a is 4, b is 20, c is 25. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to go in and put in my numbers. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Looks like that. Now we'll evaluate. X is equal to negative 20 plus or minus the square root of 400 minus 400 all over 8 is what you get when you multiply those numbers together. 400 minus 400 is 0, so we get negative 20 plus or minus the square root of 0 over 8. Now, the square root of 0 is 0, okay? Negative 20 plus 0 is negative 20. Negative 20 minus 0 is negative 20. So what you find here is that basically this is just going to be negative 20 over 8, which can be simplified. You can divide 4 into both of these. Negative 20 divided by 4 is negative 5. 8 divided by 4 is 2. We get one answer right here. We got one real root here because the plus or minus went away. That's interesting. For this one, we got one real. Okay, last example right here I'm going to do. Let's solve this one. Let's solve x squared minus, blah, 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 blah. Hang on, let me think. 8x plus 15 equals 0. Let's solve this one. Okay, so x is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so in this case, a, the coefficient from the x squared is 1. A is 1, b is negative 8, c is 15. All right, so we get negative b, negative 8, plus or minus the square root of b squared. So that's negative 8 squared minus 4 times a times c all over 2a. 2a would be 2 times 1. What is it we haven't seen? I've had only one negative every single time. Let's change this up. I'm going to change this because I want this to be more exciting. Let's make this a negative 15. And let's make this a different number. So I'm changing this real quick. So erase your papers. I'm very sorry. I want this to be 2 plus 2. Let's do that. Okay. All right. Sorry. Here we go. Now A is 1, B is 2, C is negative 15. Because I want us to see what we have to do with a different number of negatives there. So negative B would be negative 2. Plus or minus the square root of b squared, 2 squared, minus the number 4 times a, which is 1, times c, which is negative 15, all over 2 times a. Okay, that works fine. Now we use the order of operations. So we'll say negative 2 right here is negative 2, plus or minus the square root of 4. Now we have a negative times a negative, which turns positive. 4 times 15 is times 1 is 60 all over 2. All right, so right here, this is equal to negative 2 plus or minus the square root of 64 over 2, which is negative 2 plus or minus the 8. The square root of 84 is 8 over 2. So we're going to split this up. We get negative 2 plus 8 over 2 and negative 2 minus 8 over 2. This gives me a 6, negative 8 Negative 2 plus 8 is a 6 over 2, which is a 3. Negative 2 plus negative 8 is negative 10 over 2, which is a negative 5. So we got two answers, and they were both real. So for this one right here, we got two real solutions, answers. So the names of these solutions, when you set an equation equal to 0 and solve, the answers that you get are often named called solutions or roots or zeros or x-intercepts. Those, sometimes we use those interchangeably, so you need to hear those terms. Now, really quick, there is something called the discriminant. And so the discriminant is basically this part, just that part, b squared minus 4ac of the quadratic formula. So the discriminant, b squared minus 4ac, is the discriminant. And so we can figure out something that often happens. If the discriminant is positive, if the discriminant is equal to 0, or if the discriminant is less than 0, we can tell what kind, not exactly what the solutions are, but what kind of solutions we're going to get just by looking at that. So sometimes people are interested in knowing that. So if we take the discriminant and we find that it's positive, what's going to happen is we will get two distinct individual real roots. You get two real roots. If it's equal to 0, what happens is you get one real root. And if it is less than 0, you get two imaginary or complex roots. Imaginary or complex roots. So let's just look at what happened in these examples. Number 1, we had this, x squared plus 6x plus 13 is 0. Let's find the discriminant real quick. B squared, 6 squared, minus 4 times 1 times 13. B squared minus 4ac was 36 minus 52, which was negative 16. Negative, and so that would mean we'd get two imaginary roots, and we got two distinct imaginary roots. So that is what happened there. Let's look at number 2. What is the discriminant? Well, it was this part in here, right? B squared minus 4ac, which was 9 minus, let's see, 24 times 96, right? Which was negative 87. Because the discriminant, b squared minus 4ac, was negative, we should get two imaginary roots, and that is what we got. We got two distinct complex roots. I think it was the plus or minus I square root of 87 thing. So that checked out. Let's look at number 3. The discriminant was this part in here, and it ended up being 0. 400 minus 400 is 0. When it's 0, we're supposed to get one real root, and when we did this, we got one real root. We got one real root for this problem. That's what happened there. Number 4, the discriminant, b squared minus 4ac, ended up being 64, which was positive. If you get a positive one, you're supposed to get two real roots. And we did. We got 3 and negative 5, two real roots. So that is the discriminant, and that's something that sometimes we're interested in knowing, so I wanted you to be introduced to that word. Okay, quadratic formula.